we have 8 moles of A and 6 moles of B initially present. Okay? So you see the reaction, 2A plus B gives 3C. We have 8 moles of A, 6 moles of B present. But they find out, I don't know how long they had to wait, but you ended up with 6 moles of C at equilibrium. The whole question is, well, how many moles of A and B are also at equilibrium then? So what we're going to do is called an ICE table. Now the I stands for initial. It's a table. So the first row is going to be initial. The second row is the C, or change. And the final row is the E, for equilibrium. So we have 3 rows. Just have to know the tricks on filling out the rows. The initial row is simply going to be, well, you just have to read the question carefully and write in the initial amount. So one, it looks like what are the initial amounts that we can put in here? For A, you'd have 8, so you just put in 8 and keep going. 6 for B. Is there anything there for C initially? It doesn't say anything, right? If it did, you just put it in. Nice thing about an ICE table, it can handle anything. Okay. Just writing dashes for 0. So you can put in a 0 if you want. It's the same thing. Okay. So I like dashes. Change. Now, so things are going to change. I mean, you're going to change the amounts of the reactants had better go up or down. The amounts of the reactants are going to decrease or increase. Got to decrease, right? That's all. That's what reactants do. They're going to react and form products. So, and the amount of products, therefore, are going to increase. Okay. So this is where our x's come in. We don't know what the answer is, so you put in an x. Pick a variable. X. Fine. That's what they like to convention. What you do is you put in, essentially you put in x, but you're not going to have, all these guys aren't going to react the same amount. There's all these ratios. Like, and look at the reaction. There's 2 moles of A for every 1 mole of B. A is going to disappear a lot faster. So what you're supposed to do is put in the stoichiometric coefficient out front. So 2 for the, 2 for the A. There's the B has a 1. Oh, but the C I better write 3. Now don't forget the pluses and minuses. We said that the reactant change is going to decrease or effectively decrease or increase the reactant. They're going to go decrease. They're going to go down. So those changes had better be negative. Products are forming. That change are negative. Positive because it's increasing. So just remember those. Right? The change row is all of our x's. The 2 things are stoichiometric coefficients become the coefficients in the change row, and negative for reactants, positive for products. Every single time. It never changes. Now to get at equilibrium, it makes sense that it's just, to me it makes sense, it's just the initial plus the change. And we don't know what the answer is, but it's going to be 8 minus 2x for A. I didn't make my table. I should have made it bigger. For the 6 minus x. And then for the C, everybody's going to be 0, or the dash plus 3x. I guess you could write that. Well, 3x plus 0, but all right, just 3x. Okay. So you get into your mode of doing this. You fill out the ICE table. Now you check. Now the problem is just to figure out what x is. If you knew what x was, dang, here's all of your answers. You just got to know what x is, right? Does anyone see how to figure out x? Yeah. Did you hear what Eric is saying? She said that at equilibrium there's 6 moles of C. So that means this number right here, that's got to be 6. Then she even told us the equation. 6 equals 3x. how you get your X. They're going to tell you a reactant or a product at equilibrium. So you fill out the ice table first, right? Fill it out completely, all X's and things. And then you'll go back to the questions to see which one you can solve for. In this case, it's C. So my X is going to be 2. Now I know everything. At equilibrium, I'm going to have, right, let's see, 8 minus 2x, which is what? 8 minus 4. We're going to have 4 moles of A. Right? I'm going to have 6 minus x, or 6 minus 2 is 4. Oh, I end up with the same, huh? 4 moles of B. Just so happens they're the same. They don't have to be. And then they want to know the equilibrium composition, so you really should give them all. How many moles of C do I have at equilibrium? 6. Don't write 2. Because they told us there's 6. That's 6 moles of C. So this would be a complete answer.